We are starting this unit with slope, and we are going to do a lot of work with lines, but we'll focus on two aspects of slope in this particular lesson. So the first thing is just asking, what is it? The next is, how do we find it on a graph? And the last is, how do we find it in an equation? So let's get started on all of this. When we're working with lines and we're asked what slope is, slope measures the steepness of a line. And lines can either be super steep or super shallow in the positive or negative direction. So let's look at what that looks like. So first of all, with a linear equation, we read it like we read in English, from left to right. So if I'm looking from left to right, like in this first example, I would say that's a positive slope, because from left to right, it's increasing. If I look at the second one, left to right, it's decreasing. So I would say that's a negative slope. Now the other two, where we have a horizontal line and a vertical line, are special cases. So the horizontal line is one where that slope is 0. It is not rising at all. And the last one we refer to as having an undefined slope. But so far, none of these have actually given us an exact value. So we are going to introduce a proportion that we use to help us in identifying how we measure the exact value of each slope for a given line. So when we're referring to slope, oftentimes you will see the letter M. M denotes slope. So with respect to a line, the slope of a specific line is going to be rise over run. And what that means is we want to figure out how far up we go and how far over we go if we have 2 points on a line and I want to get from one to the next. We're going to do a few examples of what this looks like. Here's one example of a line, and we've got 2 points that we know clearly are integer values, so there's no estimation. And again, if we're asked to find the slope, we would look at how far up we have to go and how far across we have to go to get from one point to the next. They're not always going to be up. Sometimes your rise might be a drop. So we'll do a couple of different examples. Let's look at this instance. So here we have clearly identified these 2 points that are on that line. So if I'm asked for the rise to get from this y value to this y value, it looks like we would have to go up 1, 2, 3, 4. So we would have to rise 4 units to get from this y value to the next. That's my rise. And then we want to figure out how far across we have to go. And since we went up, that's positive. If I'm going to the right, that's also positive. So we would have to go across, that's the run, 1, 2, 3, 4, 5. So we would have to go up 4 and to the right 5. So this slope would be 4/5. So if we're asked to find the slope of this line, we would try and identify at least 2 points that we know are on that line. And it looks like this point is clearly on that line. Probably this one, that's all we need. But here's a third. So let's just quickly label those. All right, so then to find this slope, you'd notice to get from this point to the next, we would have to go down 2. That's -2. So the rise would actually be -2. The run would be to the right, 1, 2, 3. So down 2, -2, to the right 3, that's +3, so that slope is -2/3. Now we don't have to, but if we had chosen this point -6/3 and this point 0, -1 instead, we should still get the same slope. So in order to get from one to the next, we would go down 1, 2, 3, 4. So -4, and then to the right, 1, 2, 3, 4, 5, 6. So -4 over 6 simplifies to -2/3. So it doesn't matter which 2 points you use, we'll always be able to find the slope. You'll notice if we did this with a horizontal line, and I've got 2 points that I've just labeled on this, we should still be able to do rise over run and appreciate why that's 0. Because here, to get from this point to this point, we actually rise 0 units. So it would be 0 for the rise, and my run would be 1, 2, 3. And 0 divided by anything is 0. And the same thing goes for the vertical lines. You'll notice here, to get from this point to the next, so we would go up 1, so my rise would be 1, and then over 0. And that would give us a ratio of 1 over 0. That's not defined. We cannot divide by 0. So you'll see on Delta Math that they ask questions about slope and drawing lines that represent rise and run. So what you want to do for these problems is find a perfect corner for a point that you know is certainly on that line. So right here, it looks like this point, -4, 6 is on there. And you click, and then you'll see that you can drag. So let's go until, and then it looks like 0, -1 is a point on there. So let's count. 1, 2, 3, 4, down 5, that's -5, and click. And there's my segment, so the rise is -5. And then I click again to get to my run. So it looks like to get to that other point, I have to go over 1, 2, 3, 4. So down 5 to the right 4. So then we would say that that slope is -5/4. So now we're going to look at how we find slope from an equation. And the important equation we're going to be working with is y equals mx plus b. And that's referred to as the slope-intercept form. There's more coming with that, but right now we're just going to focus on the m. And remember, m is our rise over run. So when we have an equation that is written in that form, we can identify quickly what the slope is. Let's do a couple of examples. So here are 3 examples that are in that slope-intercept form. And you'll notice for all of them, it's y equals. Y equals. Y is by itself, and then the x term comes first, followed by the constant. It is the coefficient of the x term that gives us the slope. So for that top example, we would say that -2 is the slope. For that next problem, that slope would be 5/3. And for this problem here, since there's nothing written in front of the x, it's an understood 1. So that line would have a slope of 1. Not all equations are written in that slope-intercept form, but we can modify any of these linear equations so that it is. So here's an example of a linear equation that's not written in slope-intercept form. So what we want to do is we want to find the slope, and we're going to do that by putting it in slope-intercept form. Keeping in mind that the equation looks like that, y equals mx plus b. Our objective is to isolate the y. We first start by subtracting 2x from both sides. And when we do that, we end up with 3y equals -2x plus 6. And you'll notice that I put the x term before the constant because I want it in that form, mx plus b. So our next step is we want y by itself. We're going to divide everything by 3. And you'll notice every term is divided by 3. Then we can simplify that so that it reads like this. And we can see that that's now in slope-intercept form. And so from that, we can pull out what the slope is. It's the coefficient of your x. So it's -2/3. Let's do one more example. So here we have 5x minus 4y equals 12, and we want to find the slope of that line. Again, we just want y by itself. So we're going to move everything else over to the other side. We're going to start by subtracting the 5x. we have negative 4y equals negative 5x plus 12. Again, I put the x term before the constant. You'll also notice that I kept that negative attached to the 4 in front of the y. Don't leave that out. Our next step is to divide everything by negative 4. And then when we simplify that, we get positive y equals, I have negative 5 over negative 4x. Negative 5 over negative 4, we're going to clean that up. And then 12 divided by negative 4, I can simplify to negative 3. What is a negative divided by a negative? It's a positive. So our last step is identifying the coefficient of the x term, and that's our slope, 5/4.